Hello, everyone. Welcome to our first episode of Kmeleon Research Showcase. My name is Dustin Gallegos. I'm the CEO of Kmeleon, a consulting team where we design, build, and integrate generative AI solutions into visionary enterprises. Two of the main concerns when building LLM-based applications are cost and slow response times. And that's why we have focused our research this time with LLM caching techniques in LangChain. And for that, we have invited Sebastian Tafoya, who is a lead researcher and partner here at Kmeleon to tell us more about his findings. Welcome, Sebastian.
Hey, Dustin, glad to be here.
So before we start, Sebastian, can you briefly explain us why caching techniques are important in LLM operations?
Sure. So, as you said, we know that calling LLMs costs money and that each request you make takes a couple of seconds. So, this is why caching is vital for optimizing the speed and efficiency of LLM power applications, because caching allows you to optimize your data retrieval, reducing response times and server load, especially when you have an environment with repetitive requests.
Yes, I can imagine how those 1 or 2 seconds in delay can accumulate and can make your application sluggish. So which caching methods do you investigate?
Right. We found out that there are three main types of caching for LLMs. The first one is memory caching, which stores data in RAM for fast access. The second type is SQL-based caching, which, on the other hand, uses disk-based storage. Then the third and most advanced technique is semantic caching, which leverages vector data stores for matching queries based on their semantic meaning, not just the exact words.
Gotcha. So in-memory, SQL-based, and semantic caching. And out of these three techniques, how do they compare in performance?
Right. So in-memory caching is a fast option, although it's better for small data sets only. SQL-based caching is the slowest of the three options, and it may be good only for options or scenarios where you have a lot of data and response times are not as critical. And then semantic based caching is we found that is the best option all around. It outperforms in memory and SQL based caching, especially when using a diverse set of text inputs because of its ability to understand and match the query meanings.
Gotcha. Gotcha. Well, it sounds to me like semantic-based caching is a no-brainer, no?
Yeah, but just keep in mind that there are some important considerations when using semantic caching. It's important to adjust the semantic threshold setting, which determines how similar the input queries must be to get the same caching response. Also, it's important to test the behavior of your model. You have to test that it's optimal before implementing caching because model mistakes and hallucinations can be stored in memory. And also make sure you wipe out your memory when your data has changed.
Gotcha. Makes sense. You don't want to keep accumulating not useful data in the cache, right?
Of course.
So, okay, awesome. Well, this is very interesting and useful information, Sebas. Thank you so much.
You're welcome. Thank you for having me.
Yep. And remember that these and other research results are found in our blog, our YouTube channel, and our GitHub repo. All the links are available in the description here in this video. And if you're looking for to also involve your enterprise with generative AI, please reach out to us at Kmeleon.tech/contact. Until next time.